All right, in this related rates problem, we've got a story about Joe. Joe is a man who is 6 feet tall. The pole he's standing next to is 10 feet tall, and Joe walks forward at 4 feet per second. Turns out the fact that Joe is 12 feet from the pole, or whatever distance he is from the pole, is relevant. We don't actually need that piece of information. It can be misleading that you need it, but you don't. We're going to call this distance x, and we're going to call this distance y. So x is the distance from Joe to the pole. Y is the distance from Joe to the tip of his shadow. Okay, I've done this because I now have similar triangles. What I'm saying by that is we have a triangle here, and inside that another triangle. So we have x, y, 6, and 10. Back in geometry, you learned a way to represent the proportions of these right triangles just by saying long side over long height equals short side over short height. We're gonna write that out. We have x plus y, the long side, the total long side, over the total height. That's 10. This equals short side, so of the smaller triangle, so we have this short side, which is y, divided by the short height, divided by 6. Okay, this equation is key to solving this problem. Once we get this, everything falls into place. So knowing your similar triangles, that the long side divided by the long height equals the short side over the short height gives us this equation that we can then multiply, manipulate, take the derivative of, and get our answer. Okay, let's multiply both sides by 10. We're just going to cross multiply. Multiply that 6 over, multiply that 10 over. This is going to give me 6x plus 6y equals 10y. I'm going to subtract 6y from both sides, giving me 6x equals 4y. And you know what I'll do? I'll also divide by a factor of 2, giving me 3x equals 2y. Now that I have this equation, I'm going to take the derivative of both sides with respect to t, because after all, we're trying to figure out how fast the tip of Joe's shadow is moving. Okay, we're going to take the derivative. When we do that, the derivative of 3x, you might think it's just 3, but remember, we're doing related rates. So we take the derivative with respect to t. And anytime we encounter a variable other than t, we tack on d that variable, dt. So in this case, we took the derivative of x, we have to say dx dt. Y, that would be 2 times dy dt. Which of these do we have? Which of these do we know? This Joe's distance here, the fact that he's moving forward at 4 feet per second, is most directly influencing x. Every second that goes by, Joe puts another 4 feet between him and the pole. Now, it's true that the shadow is changing as well, but this number, 4, is not affecting this. It's affecting his distance between himself and the pole. So dx dt is 4. Because I have this number, I'm going to take this and plug it way into here. And this is going to give me 3 times 4 equals 2 times dy dt. This tells me that dy dt, if I just divide both sides by 2, dy dt equals 6. Now careful, you might think that's our answer, but that's merely how fast Joe's shadow is changing in length. So every time that Joe walks away from the pole, every second that goes by, his shadow is getting longer by 6 feet per second. But the question isn't how fast is Joe's shadow changing, it's how fast is the tip of his shadow moving. Joe's shadow is changing at 6 feet per second. Joe is moving forward at 4 feet per second. So in total, if we add these numbers, 6 and 4, we know that the tip of Joe's shadow is moving forward at 10 feet per second.